Okay, so let's analyze my latest Newton's cradle experiment, shall we? Because Mr. Crybaby over here keeps nagging and nagging and nagging about this Newton's cradle experiments where you have a one mass banging into a three mass, right? And after collision, they should bounce off with 1/4 of the velocity instead of 1/2 the velocity. Otherwise, we will end up with free momentum, and that can't possibly be true. It doesn't make sense. It's absolute crap. It's garbage physics. It never happens, will never happen, not true. And that's an absolute fact with capital letters, fact, underlined 20 times. It's an objectively, absolutely, factually true fact that this is garbage. Unfortunately for you, it does happen in reality. They bounce off with around half the velocity, not 1/4 of the velocity. And this has been proven to you multiple times, but of course you reject it absolutely so. So here's him defending his argument once again for the 100th time.
That they understand exactly how it's possible to make free momentum, because that's what the experiment basically does. So you start with this is a 3 mass and this is a 1 mass. You put 100 momentum in, okay, and they hit each other, and 150 flies out this way. That's what it does. 150 goes this way. The 3 moves with half the speed of the original thing. So they both go half the speed, is what physics says. Now I say it's only 1/4 of the speed, obviously, because you have to conserve the momentum. So 3/4, okay, plus 1/4 would make perfect sense. So they do leave at the same velocity, but the velocity is 1/4, not 1/2.
That's your intuition. Your intuition says it makes perfectly good sense, but it doesn't happen in reality. I'm sorry.
And that conserves the total momentum. You had 100 in, you have now 175 going here and 25 going that way. Obviously, the thing that really doesn't make any sense is if this is actually 150 and this is actually 50.
Right. So let's check out whether or not the balls bounce off with half the velocity or 1/4 of the velocity. So here's my Excel sheet. Well, first, let me show you the experiment. Yep. But this is the 1 mass, this is the 3 mass, and we have a ruler. There we go. Bang. That's it. This is the first run. So let's see whether or not it's half the velocity. Here's my Excel sheet with my calculations. So over here, so we have 4 phases. 4 phases. The first phase is 1 mass, a 3 mass is stationary, the 1 mass comes in with a certain velocity. So first we have to check, we have to measure that velocity. The second phase is they bounce off in opposite directions, and then they come back towards each other. That's the third phase. And then the fourth phase is that they collide again. They once again collide, and then the 1 mass lifts off and 3 mass remains stationary. Now we are only going to check out phase 1 and phase 2 because we want to know whether or not they bounce off with half the velocity or 1/4 of the velocity. Over here we have the mass of the ball 1, which is 6.7 grams, and then a mass of ball 3 of the 3 mass ball, which is 20 grams, which is almost a perfectly 1 to 3 mass ratio. 6.7 times 3 is 20.1. So it's only 0.1 gram off. Then over here we have the distance, the initial location on the ruler of mass 1, and then 5 frames later, the distance of mass 1 on the ruler. So I'm going to pick a time period of 5 frames, 5 milliseconds. Then we have the location of mass 2, and 5 frames later, the location of mass 2. But over here there's nothing because mass 2 remains stationary. So it doesn't, there's no difference in location. Right, so let's check it out. So right before collision. Yep, over here, and then we're gonna pick this. This is right before collision. So take a print screen. Gonna make a new file. There we go. And then 5 frames before, 1, 2, 3, 4, 5. Print screen. Right. Now let's check the difference. Let's stick. So the blue ball, you can clearly see the edge of the blue ball, which is right here, just 6.7. Over here, you can also pretty clearly see the edge, which is right here, 5.9. So 5.9 and 6.7, that's the delta distance. So 6.7 over here, 5.9. So now to calculate the velocity, 6.7 minus 5.9 divided by 5, because the difference in time is 5 milliseconds. And that gives us a result of 0.16 millimeters per second or something, or whatever. 0.16, which means that the mass is 1.072. Now, after collision, go back 1, 2, 3, 4, 5, then they collide. All right. So 1, let's take it from here as the initial position. New file. And then 5 frames later. 1, 2, 3, 4, 5. Zoom in. Let's first check out the one mass. So it's still around 6.7 here. And 5 frames later, we have a perfect 6.3. So 6.7 and 6.3 for the one mass. So let's copy it. So 6.7 and then 6.3. As you can see already, the velocity is 0.08, precisely half the velocity. Now let's check out the other one. The 3 mass. Let's see, it seems to be 7.3. Yep, 7.3. Oh, yes, and then the other one. Like right here in the middle. 6. What is that? 6.85. 7.3, 6.9, 7.3. Well, what? 6.9, 6.85, 6.9. Well, if it was 6.9, we have the velocity of 0.008, a velocity of 0.08. Perfectly half the velocity. But okay, so let's be, if we are going to be truly honest, all right, it might be 0.85, 6.85, right? Even if it was 6.85, we are very close to the half the velocity. 0.08, 0.09. I mean, all right. This is one example. It went very close to half the velocity. According to draft science here, so it should only be 1/4 of the velocity. So 16 divided by 4, 0.04 the velocity. But no, it's 0.08. And here's the goddamn fucking evidence. Real physical evidence right in front of your eyes. Once again, real physical evidence. Do you have any evidence, any physical evidence that it goes to 1/4 of the velocity? No. This is I don't know. This is not the first time we have proven this for you. So now, once again, real physical evidence that it goes 1/2 the velocity. So this is the first one. I could analyze the second run, you know, like right over here. Bang, does it go half the velocity again? You want me to do it again? I could do it, but this is the first run. Are you going to watch this video? No, you're ignoring me for now. You have ignored every single video for, man, a couple of weeks now. So you won't see this video. So whatever. So, anyway, some real physical evidence once again shoved in your face. You are wrong, draft science. Your model of conservation of momentum fails. For fuck's sake.